Hello guys. Hello guys. How are you? How are you guys? Guys, I request you to call your friends right now. We'll be beginning soon. Give me a sec. Hello. Starting in 1 or 2 minutes. You can ask your friends to join. How are you guys? You can tell me here. Did you have class today? We'll be starting in 1 or 2 minutes. There are some interesting things coming up today. Hey Ayush, how are you? Please call your friends. We'll be starting in 8:05. Okay? 2 minutes from now. How's your day? Tell me how was your day today? Did you guys make LinkedIn account? I told you na. Hello everyone. Please hit the like button. We'll begin shortly. Okay, there are some important links in the description. You can check. Okay, there are some. Okay, it's going. Okay, guys. Like, hit the like button. We'll be starting in a minute. Please hit the like and subscribe button. And are you enjoying the bootcamp session? This is the third day of your bootcamp. Anyone here for the first time? You can type in the chat. You can reply your query in the chat. Okay, like we'll wait for 1 more minute and then we'll begin, right? You can ask your friends to join. Share this link in your group. Today's session is going to be interesting. We'll be covering. There's a hidden treasure I'm going to show you today. Am I audible? Am I visible? Am I clear? Can you tell me? Can you write in the chat? Okay, cool. Okay, let's just start now. Okay. So, as you know, this is the third day of your bootcamp, cracking the code, data structures and algorithm. This bootcamp is organized by Skill Pulse. Okay, let's move ahead. So today's topic, like today's topic is going to be hashing, hasset, and hashback. Do you know what is hashing? Do you know what is hashing? Okay. Before that, let's go to the interesting part. Like, do you know about Amazon? Like what Amazon asked in his interviews, right? Have you heard of Amazon? Have you ordered something from Amazon? Tell me that. Right? Have you ordered something from Amazon? Have you ordered something from Amazon? Tell me. Have you ever ordered something from Amazon? I know you might have heard about Amazon, and it's like one of the uh, greatest e-commerce out there where you can buy or things from online, right? So in it's also one of the very good company that provides fair fair package to the like students who are joining as a freshers in SD role, right? So this is what we're going to see today, like Amazon interview experience. And it has for like 5 rounds. So first round is your online assessment. Online assessment is something that is happens over your online platforms. There are like HackerRank, HackerRat, and Amazon has their own platform where it's an interface like lead code, where the problem statement will be given and you have to enter your code and press submit. There are multiple test cases run across this solution, across your solution, and based on that you get a score, right? If there are 10 test cases, you get only 8 right, then you will get 80 out of 100, something like that. And based on that, there's a qualifying score. If you get them all correct, like they will qualify the students for the next round of interview. Then another can be your telephonic interview. Sometimes it also happens over Google Meet. So it also happens with your resume discussion, what projects you have built. And there are some lead code based problems, like you can see here it's written binary trace. Okay, online assessment, you can there ask related some graph questions, priority queues, and extra algorithms. These are all part of the DSA only. But then there are questions based on arrays and binary strings, right? Then there's the telephonic interview. Telephonic interview also has coding questions only, priority queue based and all these things. So it's overwhelming. So my point is ki you can see in both the rounds the coding questions are asked only. Let's move on and see what's there, right? So next is technical interview one, right? So technical interview also, they ask me as a lead code medium level question. So when it's a lead code, it's basically a DSA question only that is being asked, and it's on dynamic programming. We're going to cover dynamic programming in like on fifth day, so you will get a gist of it, what it is. Then again, there's another interview. It's also on coding part. So you can see like 4 rounds is totally on DSA only. So this is, you can see how much important is DSA to clear an Amazon interview, get clear the Amazon interviews, right? And this all comes with hard work. You have to be persistent, you have to keep learning and keep solving problems on lead code, right? And last is the bar raiser round. Bar raiser is the managerial round where he will ask you about, like, are you a team player, like all the behavioral questions, like have you faced any problem, how you deal with it. So all these questions are going to be here only. So yeah, so you can see out of 5 rounds, 4 rounds are purely your DSA based only. So this is how much important it is for clearing any interview in the product based companies, right? So let's move on. So today's topic is hashing, right? So do you know what is hashing? You can write it down. You can write in the chat if you know, right? So today's topic is hashing. So I'm going to explain you what is hashing is. Let me zoom a little bit. I've zoomed too much. Let me write it down, then it's clear. Hashing, right? So what is hashing, right? uh, let's check with ChatGPT what ChatGPT has to say on hashing. Hashing is a fundamental concept in computer science and data structure. It's a technique used to map data or values to a fixed size unique identifiers known as a hash code or hash values. The process of generating this hash codes is called hashing, right? So let me tell you with simple definition, right? You might have done this thing, like you might have, like, there is a camel word, right? You have a word such as camel. What you do, you just take the next letter of the dictionary and write the word down. So what comes after camel, right? So what comes after C, it is D. What comes after A, it is B. What comes after M, it is N. What comes after F, E, it's F. What comes after L, Li, right? So okay, so this is now a like coded version of this. So coded means it's like I have basically picked the next alphabet character. Okay, I have picked next next letter, next adjacent letter, you can say, and replace it, right? So this is a kind of a hashing, right? This is you have applied a hashing algorithm here, right? You have applied a hash here, and this hash algorithm is this one, right? So this is called hashing. So basically there's another thing here, ki sometimes hashing is also like denoting as something that occupies a, so first you have a string, right? First you have a string, you get a derived value of it. Okay, so you have a value and you get a derived value for it, and this derived value fits in some range, right? It fits in some range, right? It may fits in some range or it may not fits in some range. We'll see the both cases, and you will get a gist what is hashing, right? So say let's take a problem, like that would be easier for you to understand. Suppose you have books, right? You have many books. You have say maths, you have books named with physics, you have books named with chemistry, you have books named with say biology, and extra, right? Okay, there can be many books, and like what you are going to do now, you just have to arrange them in a buckets, right? So what you are thinking, you by bucket means you keep the all letter boxes, you make say what do you call containers, and you put the books in there, right? So for books starting with A goes here, for books starting with B goes here, say biology will come here, right? Again books starting with letter C will go here at this C, right? So this is how it's going to be look like. Now what you can see here, key, there can be multiple such books, right? So it goes on continuing and until you reach till Z, right? So say for Z it can be zoology, right? So you can see there are like 26 buckets, because we know there are 26 alphabets and there are 26 buckets. Now tell me but the book amount you have, it's not very great also, like you have only less than 10 books, but since you have arranged them like this, so it becomes like hard for you, means it's occupying more space basically. Okay, you'll be needing A to Z buckets to keep all the books, right? One which represents which the, and this container represents by the starting character of the book name, right? Now this is not efficient, right? Can you give me an idea like how to solve this problem? Like, can you solve this storage problem? This is having a storage problem. because we need 26 buckets. 26 buckets or containers. I'm using them like same only. So can you tell me like how can we reduce the buckets? So one thing that comes to my mind that you can think of, right? Like you can think of it as like this only. We have A B C D E, right? A B C D E. You can keep them in one bucket, right? You can name it as A to E, right? Then what do you have? F G H I J. Then you can keep it in F to J, right? Then again K L M N O. So we are basically learning ABCD here. So K to O, one bucket. Then P Q R S T. Then this is P to T U V W X Y Z, right? So this can be another bucket. So this is your U to Z, right? Now what you have done, you have said like now only 5 buckets are needed, right? So these are the 5 buckets that you are going to need now, right? Now so we have reduced it, right? Suppose say a book came which name is chemistry. So chemistry will now go to this first bucket only. We can have biology. Biology will also go to this bucket only, right? To the first bucket only. And then again we can have something like physics. Physics will go to this bucket. And say you have a subject called psychology, it will also go to this bucket. So you can see P and Q and R anything, right? Z zoology, you can see all the characters which name are starting from A to E are going to the same bucket. So this is our hash function is, right? So this can be our hash function. So what is our hash function here? Group them, take the first character of the book name and check in which bucket it falls into, right? So you are basically taking the first character of the book name and checking in which bucket it falls into, right? So this way you have reduced the number of buckets, you have reduced the number of containers. Now if you have to search for any book, suppose say biology, you will go to this bucket first and you will scan, do a linear scan across all the books you have, right? So this way you have saved the storage, you have solved the storage problem. So this is your hashing function, right? Now say what about numbers? Let's talk about numbers. So you have say number n equal to a very big number, right? 189, right? Now you have multiple numbers such as like this only. You have 189, you have 206, you have 101, you have 54, you have 38, like this. You have such a huge numbers, right? Now you want to store them in some buckets, right? And you don't know what's the maximum range of the bucket also, right? There can be a number which is like 1922, right? 1992. So is it feasible to make one bucket for each number? Like can we make 1 to 100? That way we are not sure how many buckets we'll need. Even if we know the maximum length, we will need 2000 buckets, right? What we can do, we can limit this into 100 buckets also, right? How we can take the 100 buckets? We can say it like this: 0 to 10 will go to one bucket, 11 to 20 will go to another bucket, and 20 to 30 will go to another bucket, 21 to 30, and so on, right? And you can also see yeah, that's how it's going to be. Then again, if you want to reduce it further, if you want 10 buckets, right? If you want 10 buckets, that thing also you can do, right? But how to decide how to which bucket should number fall into, right? So which number the number should fall into, right? So say we have 10 buckets, and all these buckets have some numbers, right? Let me take an array here so it will be easier, right? We have 10 buckets. You can think of these are the 10 buckets, right? These are your 10 buckets. Now say we have 189. Can you think of any algorithm, like hashing algorithm, like how will you decide which bucket to put? Now that's the question, which bucket to choose. Can you decide it? Like first we are getting number n equal to 189. So we can choose the bucket ID. We can define our algorithm like this, right? Let me go below. Okay, so we can decide our bucket ID like this. Bucket ID is equal to n modulo 10. So you know modulo is the remainder when we divide the number by 10, right? So in this case 189 divided by 10 gives us remainder how much? 9, right? You can write it like this only. You can write it like this: 18 into 10 plus 9, right? So this is how you will get the this is my 9 is my bucket ID. So this 189 will go to this bucket, right? Let me write it small or large, right? Then what about this number 206? It will go to the this bucket, right? Then again this one will go to 101 will go to the this bucket, right? Then we have 54 will go to which bucket? Can you tell me? It will go to this one, right? Because 54 when divided by 10 gives us 4 as remainder. What about 1992? It will go to this bucket, right? So can you see like how we have decided which bucket it will go to? Now if we have to search for any number, we can easily get to that, right? So that was how like hashing works, right? So that is how hashing works. So hashing can be like this is n modulo 10 and modulo bucket size. This is one of the your what do you call it? It is one of your hashing algorithms, right? Modulo as hashing algorithm. Now there can be many more when it comes to a number, right? There can be many more. Suppose say you are this is one of the hashing algorithms. There are another hashing algorithm which is very popular. Suppose say you have any number, right? Let's call it a 9-digit number only. Okay, so you can break it in 3 parts, and what you can do, you can add their parts, right? You can add 123 plus 898 plus 389, right? And this will give us something, right? So say it will give me 9 12 18 20, 2 comes here, 9 to 11, 13 plus 7 21, and then 2 again, then 5 6 14, so 1410. Now if we have to like, we can keep on doing this until we get a bucket that is under 1000, right? Now it's a number 1410. Again we can break this part, like we can keep continuing like this. 1, it will be 410 plus 1, right? So it becomes 411. So this is my bucket number. If I have decided key there will be 1000 buckets, right? So you can divide it in sub parts and keep adding them till you get required number, right? So these are all hashing algorithms, right? And this is not limited to this. There are many uses to it. So hashing is like you have a value and you are getting a derived value. This derived value may fit on some range, right? So this is one of the use cases, and you will see these use cases later. And another use case of hashing is basically getting a derived value that is encrypted. It's used for encryption. Suppose in a database, you taken an input of password, like something like mango, and what you will do, you will do a hashing with it, right? So for hashing, you can see, you can apply anything, right? You can take the next letter of it, right? If it is like NB, for N is O, for G it's Ace, and O for O it's P, right? So this is an encrypted number. Now anyone who sees this string would be confused, like, is it the password? If he tries that, it won't work because it is an encrypted form. So there are two use cases of hashing. One is like you can say encryption, and one is fits into range. But the thing is, like for this you can see, like 206 has gone here. Now can from 6 we can derive 206? No, it's not, right? So so it's not always the case. So you can encrypt it only if there is no data loss, because you can see there are 6 characters, and in the output also there is a 6 characters. Now if I have to derive the value from it, I will pick the leftmost character for it, right? Means I will pick the previous character for it. For N it's M, for B it's A, for O it's N, for H is G, and for P is O, right? So we can get the like coded value back. So this is one of the use cases of hashing. And another one is key, we can get a value that can fit into a range, right? So that is lesser than that. So these are the two use cases of it. So did you understand till here? You can write in the chat, do you have any doubts? Right? Okay, now let's come to the interesting part. So before we proceed, like, this is the third day of your bootcamp, and hope you're enjoying it. And today's topic is, as you realize, is hashing, hashset, and hashmap. Now if you are aware, we have a campus ambassador program. So campus ambassador program is for the one who wants to build a leadership skills, get certificates, and get free resources, and want to be with touch with us and work with us. So it's for them only. Your roles and responsibilities will be told by your team member, which is basically organizing events and asking your friends to join the bootcamp and all these things. Yeah. And now to the attendance. So I have put the attendance here. One sec. Okay, this is the one. So this is the attendance link. I know you are aware. I put the Telegram link here. You can join our Telegram group. We'll be posting about our events there. You put your name here, email here, phone number, WhatsApp number, college name, year, branch, and if you're interested for campus ambassador programs, you can fill that also. Also, main thing is I haven't said it. I'm sharing this attendance link. You can take your time filling the attendance, and I have also added them in the description. You can check the attendance. And also for the previous bootcamps, whoever have missed them, will keep checking the description. We will be posting them well, 45 days it will be live. You can go ahead and watch the bootcamp and mark your attendance there. So keep checking the descriptions of the earlier bootcamp sessions as well. Okay, and yeah, take your time and mark your attendance. I'm waiting for you. Yes, it's the attendance form. For the earlier bootcamps, we will be giving you, you can keep checking the description, you will get that. Yeah, this is the attendance forms. Please go ahead and mark your attendance. And whoever is marking the attendance for the 5 days, as you know, will be giving them bootcamp certificates, right? So make sure you mark your attendance there. It's on the description, and for the earlier bootcamps you have missed, we will be posting them, so you also get that also. Posting them in the description of the video. Okay, cool. So So let me introduce myself. If you are coming for the first time, let me introduce myself. I am Tasreel Ali. I did my graduation from, and this is my LinkedIn profile. I did my graduation from IIT Dhanbad. I have been working as a software engineer at Uran. Then I'm working as a backend developer at Cred, right? And this is my LinkedIn profile. You can send me a request. You can send me a request. It's already in the description. If you want it, I'm posting it in the chat as well. Right now, there's a giveaway contest. Right today, we're thinking of doing a giveaway contest. This giveaway contest is just that go make your LinkedIn account. It's very important for your career. You will remind me after, like, you will remember me when you get a job through LinkedIn. It's very effective to get internships and job. So do make it. Now go here and make a post here. Make a post like attended Skill Pulse Bootcamp today, and you can post all the things I have learned. Right? You can talk about the hash map. You can talk about the hash set and all these things you have learned today. You can post it like this, and do make sure to tag Skill Pulse. Right? Take this brain looking symbol, right? Brain running symbol, Skill Pulse. Just make sure to tag it, and whosoever is do this, will be giving them free resources. And it's not free, means we'll be giving them some good resources, right? So it's free only if you are doing this task for us, right? So we have a list of top DSA problems and the list of top IT companies, and this is not the very list. Also, we are planning to give t-shirts whoever whoever got lucky, right? Whoever got lucky by taking part in the contest, will be giving them t-shirts also, right? So do make sure to do this LinkedIn task. It won't take your time, and you will get to learn about the LinkedIn interface as well. You can download from Play Store also. It's available on Play Store. Okay, cool. Shall we move ahead? Am I clear till now? Like, do you need anything from me? You can tell in the chat. Otherwise, we'll move on. Okay. Let me check the chat. Okay. So now we are going to take a look on hash set, how it's going to be. Actually, I have explained much of it early, explaining the hash set, hashing. So let me explain you what is hash set quickly. So this is your hash set only, right? So what is mean by hash set? So you are getting a value, right? You apply your hash function there. So you have applied the modulo function here and put that value in that index, right? Or in that index we have put it, right? Now if you have to search for that value, what you can do, right? You have to search if the value is present or not, right? Let's take this example only, right? Now say let's take a fresh example, right? Let's take a number n equal to say 5362, right? Now what we have done, we are taking the modulo by 10, right? So 5362 modulo 10 becomes 2 only, right? And modulo 10 gives us 2 only, right? So we'll put this 5362 number in this index 5362, right? Now a query comes, you have to search for a value 5362 and say it is present, do you have this number or not, right? The query may come later, right? You have do the insertion at the beginning and the query may come later, can you tell me, like, do you have 5362 or not, right? So what I can do here, I can again apply this function. I will again apply the hash function and get the value, right? Now I know which bucket if my number should lies, right? So I will check here only, like I can do a linear search here. I can find if 5362 is here or not, right? If it's here, then I will say yes, it is with me. If it's not, then we'll say no, it's not with us, right? Again, if we get a number, say 606, we'll again do this modulo function, we'll get 6 here, and we'll see if 606 is in present in the bucket 6 or not. No, it's not, right? So that's how we're going to use a hash set function. So it's like hash set helps you to determine if the number is present in the hash set or not, or you can say it's present with you or not, in very efficient manner. Suppose you stored them in an array, like you keep them storing in an array, and it may grow huge, right? It may grow up to like the numbers you have, it may grow like the number of numbers you have, right? So in that case, for searching in an array, your time complexity becomes, you have to search for array of length n, right? So your time complexity becomes O of n, right? But in this case, your time complexity is much less than O of n, because you know the bucket. It's almost there's a thing called average complexity. This is the worst complexity, this is the maximum it could take, and this is the average it could take, right? So average is written, there's a phi symbol here, I don't get it here, let me write it like this. Okay, so let me take a light symbol. It's like this. So this is your average complexity, right? This is your average complexity for this hashing function, because you know which bucket it will lie, you can easily find that that number is there or not. So this is how hash set is implemented, right? Now we'll see a problem that after that it will be more clear, right? Attendance link is above only, you can let me write it here. Okay, now let's take a problem for it, right? So intersection of two arrays. Okay, we can type it here only, not a problem. So we'll go to this intersection of two arrays. This is available on LeetCode, right? You can search, do a Google search, or you can easily get it, right? Or I can share the link if you want. Okay, now let's read the problem, right? Given two integer arrays num1 and num2, return an array of their intersection, right? Right, so what do you mean by intersection? So do you know what intersection is, right? So let me explain you here. So there's an array where there are numbers, right? There are numbers like 1, 2 is there multiple times, then there is like number 4, right? Now there is another array, this is my array 1, and there is another array, let me copy this. There is another array, let's say array 2, and this has some 2, 2, 3, right? 3, 1, 5, right? So when I say intersection, you have to take the common elements from the two, right? So when I say the intersection of both the arrays, you have to take the common elements from the two. Now you can see what is common in there, right? And you don't have to repeat the numbers. You can see, is 1 common in both? Yes, it is. So in the intersection, 1 will come here. Again 2 is common, again 2 will come here. Can you find 4 here? No, 4 is not there. 3 is present only one of the arrays. 5 is also present in array 2, not in array 1. So this is my intersection, right? So this is my intersection, right? So this is how you are getting the intersection. So you have to find the common elements in the both arrays, right? Now can you think how we can use how we can solve this problem, right? So you can think of it as like key, say So this is my hash set, right? So this is my hash set. What we'll do, we'll process this array first, right? Let me write the algorithm like this. Process array1 and insert, it's too big, let me take L, insert in hash set. Then second, like process, by process I mean traverse or like iterate, right? We are traveling the array elements one by one, right? Like using a for loop. Then again we'll traverse array2, and what we'll do, check element in hash set, right? If present, add it to result, okay, and remove from hash set. And this is how you have to continue. Now let's see how is it going to look like, right? So so let's take some big numbers, right? Let's take 51, let's take 21 was common here, say, right? So 21 was there in both, right? And then there is like 43, okay, and something like this, right? So it's for you to understanding ki like their numbers can be big also, okay? So you can see 1 and 21 is common in both array, so this is my intersection. Now what we'll do, we'll traverse the array 1 and put them in a hash set, right? We can put the number 1 in a, we'll put the number 1 here because it's in the hash set only, right? There can be, one can be repeat here also, it's not a problem. Then we'll again get 21, so 21 will again go where, like 21 modulo 10 is how much? It's 1 only, right? So again 21 will also go here. I'm not able to write here. 121, right? Again I will get a 1. Again 1 modulo 10 will go here only, right? So again it will lie here only. But since it's 1 is already present, we don't write in unique values. Means only unique values are present in the buckets. Again we'll get 44. It will be present here, right? Now what we can do, take a small one, right? Again I can take the small or medium one, right? Now what we can do, we can traverse this array now and check if 21 is present here or not, right? We'll check 21 is present here or not. We'll check here and we'll check if 21 is present in the hash set or not. We know 21 modulo 10 is 1 only, and we'll go to this bucket and check if 21 is present or not. Yes, 21 is present, so we'll add to our result, 21, right? Then again what we'll do now, we'll remove this element 21 because it has been processed now. Again we'll go to 21, again we'll do this modulo function, and again we'll get 1, but this time there is no 21 here because we have already removed it, right? So this 21 won't be get added, right? Then again we'll get 3 we'll check here, 3 modulo 10 is 3 only, and we'll check here, no, it's empty, so we'll again move on. So again we'll check 1 modulo 10, which is again 1, we'll check in this bucket, and we have found 1, so we'll again add 1 to our answer and remove this element, right? Again we'll go to 51 modulo 10 is again 51, but 1 is empty, so this is my final answer, right? So did you understand this part? We'll write the code for it. You can write in the chat. Okay, so how to write, how to declare a hash set, right? Let me write the comments as well. Do you know how to declare the hash set? Do you know what STL we have to use for declaring a hash set? You can write in the comments. Let me write it down. And what should be the data type? It should be int only, right? Now this is my hash set. I can write it like this, right? Now what I will do, I will do the process or like traverse first array and add to hash set, right? Now earlier I have taught you like how to iterate an array using a for loop. There is another call as for each loop, which is very easy to write, right? You just have to write for int, you just have to write the variable name it will take each time, and you can write it like this. So x will occupy each of the elements value. For first iteration it will be 1, then it will be taking 2. So for the first loop it will be taking 1, then it will take 2, then it will take 2, then again it will take 1, right, according to this array. So this is how it's going to be look like, right? Now what I'm going to do, I'm going to put it in the hash set. So I have to use this function hash set insert x, right? And even if there are unique multiple values of the same type, means if there is repetition, it will be only inserted once only. Now what we have to do, we have to traverse second array, right? Before that we have to return a vector. Vector is similar to array only, you can declare it like this, but it's easier that way because you can add values to its back. I will show you how. So again we'll iterate the second array, right? Now what we'll do, we'll be using this query and query or this count function, which will tell me like if x is there or not, if x is inside this hash set or not, right? If it's there, it will give me true. If it's not there, it will give me false. If it's there, then what we have to do, we have to add it to our answer, right? So this vector is a dynamic array. It keeps on growing until you it's started with an array like this. Now when I push here, so the value get added. Like when I use this pushback value, the x got added here, right? And again I'm pushing another value, x means x, first x1 got added, then x2 got added. This is how it's going to grow, right? So I will add x here. Now there's an important step, right? The important step here key, we have to remove it from the hash set, right? We have to remove it from the hash set, and finally we just have to return the answer, right? Let's see, let's run the code and see the output. So you can see we have qualified like for the first case only 2 is common. Now what would that happen if I don't erase this, right? If I don't erase this x after processing this, what do you think the output would be? It's giving me wrong answer because 2 is printed twice. It's the same thing only. This 21 would have been added again if I haven't removed it from the first processing, right? So this is how you use an hash set to implement this function. Let's go again. I have declared a hash set. I have pushed all the values in the hash set. Then I'm iterating for the second array. I have declared my answer vector, and I'm checking if the hash set has this value. If it's the case, we am adding the answer, and I'm also erasing the value from it, and finally I'm returning the answer, right? Very simple. I will do submit and let's see the output. Right, it's getting it's getting accepted. So this is how a hash set works, right? Now let's continue. Did you understand till here? Like if you have any doubts, you can write in the chat. Okay, cool. Let's continue. So now we are going to learn about hash map. So hash map, so we have learned about hash set. Now we will learn about hash map. So hash map is very simple, right? It's similar to hash set only, but like instead of keeping what do you call it? Instead of keeping the key, like there's a pair, right? Instead of keeping a single value, there's a pair, right? So say so you have to implement a phone book, right? You have to implement a phone book, and there are like names and numbers to it, right? Or let's let's take the name. Like you have name ABC, which have number like 1 to 3. You have number like ball, which has number like 213. You have number like cat, which is like number is like 672. It's like that only, right? Now what you can do uh, what you can do is basically use the same concept as before. We'll be doing the hashing only, and we'll be saying ki all a all a to all starting with a to e will go to this bucket. We'll say again e to h will go to this bucket, and so on, right? Like we have seen earlier, right? We can use that. So we'll be using hashing and keeping this value. So for this abc will go here, but now when we're storing it here, we are not going to store it like a number. We'll be storing it like this only. We'll be having abc as the key, but we'll be also storing the value here, right? Again we'll get ball, so ball will again come here. So instead of storing like ball here, we'll be storing like this only, ball 6234. Then again take some like a big number, say kiwi, let's say eagle, right? So eagle will go here. So it's the same only, right? It's the same only. Like when I'm storing 44, I'm not saying 44 is getting stored alone here. I'm saying ki along with 44 there's another thing, right, which represents a value, right? It can be anything. It can be a number, like it can be a number, it can be a string, right? It can be a character. So it's stored in a key value pair, right? So that's the only difference here. It's stored in a key value pair, right? And which was earlier the key only, right, in hash table. So in hash map, and this is in case of hash set. In hash set we just store the key only, right? And we can check only if it's present or not. But in the hash map we can check if it's present or not. That thing we can check. Along with that we can also check what this key represents, right? What this key represents, we can also check that. So if you have to implement a phone book, you can think of it like that. You have the name of the persons, you have the numbers against it. You can use the phone book. You can optimize your search by searching efficiently on the names. But his name is going to help. Suppose you have to call Rahul and you have used your hash set using this. You have because you will search by Rahul, right? Because you will search by the name, right? But what the part you are interested in? What you are interested in the phone number, right? So this is your value and this is your key, right? You will search by the name, but the part you are interested in is the value only, right? If you have to search the phone numbers for eagle, right, you can search your hashing function will lead to this bucket. You will search this bucket, you will get eagle, and you will get the number here, and that's the number you are interested in. So that's how hash map works, right? Did you understand this part? It's very simple only. Also guys who are joining late, like I'm you can check the attendance form above. It's also in the description. You can use it to mark your attendance, right? And also there's the campus ambassador programs. You just have to tick the campus ambassador in the attendance form, or you can also have found the link in the description if you're interested for the campus ambassador. So this is how hash map works, right? Now let's see a problem. So this is a problem. Given an array of integer nums and integer target, return the indices of the two numbers such that they add up to the target, right? So this is my question. So what I'm given here, so you're given a let me clear this up. So you're given an array users have to find the indices which adds up to the target. So it's given here as 2, 7, 11, 15, right? And target is 9. So let's take array. Okay, so we are given here is 2, 7, 11, 15, and we are given a target. So target is 9. Now in this question is asking key users have to return the indices, right? You have to return it as an array, like for which the values sum add up to 9, right? So you can easily see 2 and 7 is the answer, right? For target equal to 9, 2 and 7 is the answer, because indices will be values will be 2 and 7, and what will be your indices? Indices will be 0 and 1, right? Because these are present in the 0th index and the 1 first index, right? Now if you have to search for a target, say 13, so if you have to search for target 13, so it's 2 and 11, right? So 2 and 11 is there, so in this case you have to return 0 and 2, right? If the number is not present here, say target equal to say 50 is not possible here, so in this case you can return indices equal to -1, -1. That will tell you okay, it's not present here. Now can you think of the solution, like how you can what data structure you can use? Now since we are learning hash map, you can easily predict key we just have to use hash map only here, hash map or hash set only here. So can you think of the solution, right? So let me explain it to you, right? Say we'll be traversing this array and we'll be keeping a hash map, right? And what this hash map will have? It will have index to it will have value to index relation, value to index key pair, right? It will have this. Now how is it going to work? You can check it like this. So we are standing at the first index, so we are using, say we are iterating using a for loop. So axis, we won't be using a for loop here, we'll be having to use an like, let me write the pseudo code here so it's more clear. So first we'll be declaring a hash map, right? So let's say this is my hash map, so I can write it like this. Map of incoming. So let me write it easily, so it's a pseudo code only, right? So now we're iterating for I equal to 0 to n minus 1, right? Now what we can do, this is my like what do you call, search function, right? To sum function. Here I'm already getting an array, right? Here I'm also getting an n, right? Now what I'm doing to check here, key I'm declaring a hash map here, and we're checking key if it's present, if it's first of all, if I'm checking if hash map has this or not. So hash map dot count, I'm checking this value, so this is array of I. Sorry, it's not array of I. Can you think what we need to search in the hash map? Suppose we are standing at any of the position, say we are standing at 7, we want to check if there is any number behind 7, like before 7, which can be given as the target value, right? So say if we are at the 7, what is the number that we're interested to search for, right? If x is equal to 7, say standing at index I, so what's the number you are interested to find, right? So our interest, or like we want to search, is target minus x, right? That is 9 minus 7, right? So we can search for 2 here, right? So what we are going to do, we are having a hash map, and we'll be putting the number against that value right, and checking. Say if you are standing at any position, we are going to check if this is present or not, if this value is present in the hash map or not. If this is present, that means it has occurred before 7, right? And from that we can get the 2's index, because we are storing the 2's index only, right? So 2's index is 0, and from I we already have this, right? So from the map we can get 2's index, and we can get this I, we can return this both as our answer, right? So that's how it's going to work like. So say say we are starting at 2, right? Let me write the whole code now so it will be more clear. So first of all we have to determine your search, right? Search will be target minus array of I, right? Array of I is like you can call it X only. Now what I'm searching the search, right? If it's present, right, if it's present, we can get our answer like this. We can get our answer, our first, let me write it like this so it will be more clear. So first index will be hash map of this array of I, right? Sorry, hash map of this search, right? And we will have this second index, which is, you know, it is I only, and we can return this as an array, first index and the second index, right? Now this is the case when we have searched this value. Now if we don't search this value, suppose we are starting at 2 only, and for 2 say we are access 2 and I is equal to 0, we will search for this target minus 2, right? Target minus x. Target minus x is 9 minus 2 only, right? So 9 minus 2 is 7. So we'll try to find is 7 in the hash map or not. No, it's not, because we are only storing which we have covered, right? There is no element before that which is 7, right? So it gets added to our map, right? So in the map we store it like this. So we store key value is 2 and the key is 0, right? Now this is my map. Now what we'll do, we'll be going to this position. Now we are now here at this position at 7, right? Now we are at 7, we have I equal to 1, we have determined search equal to 2. Now we can easily find in the map 2 is present, right? 2 is present, so we can easily get our answer like this only. So am I clear till now? So there is one more step that is left here. So if it's not present, we won't be returning from here, we'll be adding it to a hash map. So in the hash map we'll be we'll adding this like this. So we'll be adding the value here first. So it is array of I is equal to I, right? Am I clear till now? Did you understand like how it's going to work? You can write in the chat if I'm not clear. I'm happy to repeat. Okay, so let's go on writing the code, right? Let me write it here so you can see it, right? So first of all we have to declare the hash map, right? We have to declare the hash map. So how do you declare the hash map? It's similar only. One sec. You have to write it unordered map, and it is int comma int. I can name it like empty, right? Now what I'm going to do, I'm going to iterate this for loop, right? 0 I is less than nums dot size. I can write, because it's same as getting the n only, or you can write it like this only, int n equal to nums dot size, and this is my n, right? I plus plus, then we'll be iterating this. Now what we're going to check, we'll be checking if mp, first of all we'll be calculating the search, right? So search will be target minus array of I. We can declare it like this only, so it's more clear. Array of I we can call it, and we'll be searching this. Search is equal to target minus x. Now we are trying to find this. If mp dot count search is present, right? If it's present, and what's the case if it's not present, right? um, if it's not present, let's write it down. So I'll be taking the first index, so I can call it first. So first will be mp of search only, right? This will give me index. And second is no, this is the ith only. And lastly we'll return a vector from here. We can declare a vector from here only, like this, right? We can write it like this without giving any name. And finally it's getting returned. Otherwise, if it's not getting returned, we'll be adding this here. So we'll be adding, what we have to add here, we have to add the value and against it the index, right? And finally we have to return this value here. We have to return, what do we have to return? We have to return -1 if we're not able to find it, right? Now let's run this code and see if it works or not. Okay, there's an error here. Okay, array is not array, it's nums. Okay, and yeah, let's try to run again. Okay, it's coming to be true only. Let me remove this code, right? Let me try to submit. Okay, so yeah, it's successful only. So again I'm repeating, we have declared a hash map. We are iterating the array. We are getting the target that we need to search if it's in the hash map. From the hash map, if we get it, then we are taking the index of it, right? We need to return the index. So it's the first index, second index is I itself, and we're returning from here. If it's not there, we are setting in the hash map the value for the value against which there's the index, right? So this is how this problem works. So hope you understand. You can type in the chat. Do you have any doubts, or we can move further? So this is your assignment, intersection of two arrays. This is the problem link. You can solve it. You can try solving it. I'm not going to explain you. This is very similar. It's a similar problem as before only, but for now users have to also return the number of counts, right? Means number of intersection. If 2 is there 2 times, you have to return it 2 times only. So you may figure out key, instead of hash set we have to use a hash map here, right? And it's up to you. Go ahead and figure it out and solve it here and let me know in the comments, right? Okay, so finally we are reaching at the end. So thank you again. Hope you have seen the attendance link. You just mark your attendance. It's very compulsory for you to get certificates, and we'll be posting the attendance links for earlier bootcamp sessions as well in the description. So check out the YouTube description for them. So I think that's it from my side. Do you have any doubts? You can ask. Otherwise, like, we are good to go. And yeah, like a very good night. Sleep tight. Okay, so yeah, bye guys.